Hey guys, Mr. Middleton here. Today we're going to talk about relations and functions. At the end of this video, you should be able to represent relations in a variety of ways. You should be able to identify the domain and the range of a relation, and you should be able to differentiate between a relation and a function. Okay? A relation is a set of ordered pairs. Ordered pairs. Okay? And we can show relations in a bunch of different ways. We can list them as ordered pairs, we can graph them, we can make a table, and we can make a mapping diagram. And we'll show all of these and see all of these today. Okay, a relation is made up of two parts basically: the domain, which is the x values, or sometimes they're called the inputs, and the range, the y values, also known as the outputs. Okay, so like said, the domain is the x values and the range is the y values. So what I want to do is I'm going to list the domain, which is just the x values. So these values here, I'm going to list this, and what I typically do is I will list them from least to greatest. Okay, you might see them written other ways, not least to greatest, but I recommend doing least to greatest. And then the range is the same thing, except it's the y values, all the y's. And so again, from least to greatest, -1, 4, 7. Okay. Notice that when a domain or range value is repeated, we only need to list that repeated value once. So here you see that there's -1 twice for the y's, but I only wrote it one time. Okay. If it's a range value, I only have to write it once. Or a domain value, either one. So, like I said, you can have a list of ordered pairs, just like we had here, or we can have a table here. Again, the domain and the range don't change. Our x values goes first, our y goes second, and so as I list my domain, I have 1, 2, 3. Okay, 1, 2, 3. Again, I do not repeat that 3. My range, I'll have 70, 84, 92, 99. Okay. So there we go. Using the x and or just listing the x and the y values, no repeats. Again, we can see in a relation as a graph. So remember that all these points have ordered pairs that correspond with them. So I know this is just a point here, but we can have, this is -3, 2. This point is -2, 1. Okay, each of these points has a coordinate that goes along with it. Okay, so this would be 3, 2. Okay, so we can list those coordinates out if that helps you out at all. If not, that's fine as well. But we'll take all of our x coordinates, and I'm just going to look from left to right. -3, -2, 0, 3. Again, notice that I did not repeat the 3's, even though there's 2 of them. And I'll do the same thing with the range, except I look from down to up. -1, 0, 1, 2. Again, notice I did not repeat the 2's. Okay. Alright, so a relation, set of ordered pairs, the domain is the x values, the range is the y values. Flip them to the back side. Okay. A function is a relation that assigns exactly one value in the range to each value in the domain. In other words, a function is a relation in which the x value does not repeat. Okay, the x value does not repeat. And in that I mean if I put in a value for x, I know what comes out of it. Okay, I always like to think of a function as the word, does it work? Okay, that's kind of how I like to do that. And so I think of a vending machine, which we don't have very many just like sitting around anymore. But if you go to a vending machine, you pop in numbers. Okay, I'm trying to draw that really quick. Okay, if I push a number, then I want to make sure that I know what's coming out of the vending machine. Okay, that's my input. When I input something, I know what's coming out. Okay? A vending machine won't function if when I input something, two things can come out. Okay, and we'll see this a little bit more later as we go through some examples. Okay? Okay, so a vertical line test is another way that we can judge or test if a relation is a function. Okay, if any vertical line passes through more than one point in a relation, the relation is not a function. Okay, so let's look at some examples here. And so with your vertical line test, you can take any straight edge, okay, and hold it vertical. And if at any point throughout the graph it goes over two lines at the same time, and notice here, it does. Okay, there's 2 points that it intersects at the same time. This is not a function. Or sorry, yeah, not a function. I said that right. Okay, and here's what I'm saying about the vending machine. Notice that my input is 3. Okay, if I just put in 3, I don't know if I would get out 0 or if I would get out 2. Okay, I'm probably not going to use a vending machine that I don't know what's going to come out when I know what I'm putting in. Okay, so this is not a function. Same here with this circle. Now there's more points here, but notice that if we write a vertical line, so I'm trying to do a vertical line here. Okay, notice that our vertical line intersects 2 points at the same time. We could do a bunch of those. Okay, and so again, this is not a function. And then a parabola, or a U-shaped curve here. Notice that as we go through with a vertical line, that there's no time where it's overlapping 2 points at once. Okay, it's a continuous graph, so yeah, all the points are really close, but there's no time where it's overlapping 2 points at once. So this is a function. Okay. And so that's us using it visually. And now we can look at a set of ordered pairs. And so what we'll do first is we'll look at the x's. Okay, 4 goes to 9. -2 goes to -2. 0, 4, -2, and 5. Alright, and so I notice here, hold on, I have a -2 and a -2. Okay, it doesn't disqualify it to have -2 listed twice, but that should mean that the y should be the same for both. When I put in -2, the same thing should come out. My input should always get the same output. And so notice here, I won't know if I have a -2 or 5. And so this is not a function. Okay. And then here, we have -1 to 6, 3 to 6, 6 to 6, 7 to 6. Okay, a lot of people would be quick to say this is not a function, but notice I know what I'm getting out when I put something in. You guys have ever gone to like I don't know, some health food stores or some gyms or something like that? I've seen vending machines at gyms that they're all waters. They don't have any kind of flavored drinks. Okay, and so it's all Dasani, all Dasani, all Dasani, all water. So it doesn't matter what I put in, it doesn't matter what my input is, I know that I'm getting a water out. Does this vending machine work? Yes, I know that when I put in something, I'm getting the same thing out. So whether I put in -1 or 3 or 6 or 7, it's going to come out to be 6. Okay, this is a function. It works. All right. Let's look at a mapping diagram. Mapping diagram is just another way to tell if it's a relation to the function or not. Another way to just write out our ordered pairs. And so what we do for our mapping diagram is that we'll plot the x's in the domain in one of the ovals and the range in the other oval. Okay, and so I'll do number 2. I'm going to leave number 1 for you guys to do. I believe that's what I said to myself. Okay, and so let's look at number 2. We're going to list the domain the same way that we listed it before, so -1, 0, 2, 7. All the x values, no repeats there. And then I'm going to do the same thing with the y's. I have -4, 3, 8. Okay? And so now what I'm going to do is I'm going to go through and I'm going to connect all the points with a line. So 7 to -4, 2 to 8, -1 to 3, 0 to 8. Okay? Now we're asked, is this a function? Again, we're focused on the x's. Look here, we look at our x's and we say, when we put in something, is there a chance that we'll have 2 outcomes? 2 or more outcomes. So when I put in -1, look, if I put in -1, I know 3's coming out. If I put in 0, I know 8. If I put in 2, I know 8. If I put in 7, I know -4. So there's no button or number or input that has 2 different outputs. So then it does function. It is a function. So try that with the first problem. Hopefully you can tell the difference between relations and functions. You are able to read that on the table, a list of ordered pairs, a graph, or a mapping diagram. All right, see ya.